Okay. Okay, so again, good morning. Let's start the lesson. Right now, we have 21 participants. Okay, and I'll just admit everyone who will be on the waiting room. Okay, by the way, I'm Engineer Paulo Bersamina. Oops, Engineer Juan Paulo Bersamina. Okay, so I'm also a graduate of TUP, I think 2007. Yeah. Then by 2009, I started my master's in UP, and then I graduated just 2016. So it took me 7 years, almost 7 years, to finish my master's because I'm also doing my full-time job while doing my master's. Right, so 2009, 2008. No? I'm in DCCD Engineering Corporation, and a consulting firm. I think some engineers here know that. My projects there was land development, okay, flood study. That's why I'm also aware on flood analysis, okay, land development design, okay, reservoir design, okay. Then I my stint there was 2 years. Okay. By 2010, I'm in Eigentech Corporation. This is a geotechnical engineering company. So in DCCD, I'm a civil structural, but in Eigentech, I became a geotechnical engineer. Okay. But since this is a small company, uh, like other company, it will accept civil structural job also. Okay. But unlike with DCCD, the land development project was way bigger than Eigentech. Okay. Our client here in DCCD is Ayala, okay, Landco. Okay. But in Eigentech, mostly uh, Mormons. We design Mormons churches. I designed in Bicol, in Kamalig, in Tarlac. Okay. But but Mormons church, as you will observe, are is just a template. There's a template already. Okay, so you'll just change the foundation depending on the site location. Okay. So civil structural, but the bread and butter of the company is geotechnical. And then by 2012, I got my first multinational job in Versar International. Yeah, Versar International. So here, take note, while having my jobs here, I'm already taking up my master's in UP. So I got that bit of confidence to reconcile the theory, by the master's degree and the actual application in the industry. That's why I go back to the academe, try to share it with you, and and my approach is to reconcile the theory and the actual application we're doing in the industry, okay, and why the software is doing this analysis, how to troubleshoot software, okay? Because in our age, in our uh, the current trend is mostly software based, right? Especially in this pandemic, we rely on software because we cannot do things face to face. Versar, our projects here is Afghanistan. So the military bases, uh, when US occupied Afghanistan, of course, they built Afghanistan. So we are the project managers. It's an outsourcing company. We're based in Manila. And here I started to be conscious on the code. So for the structural engineers or civil, because we check the code compliance of the contractor, their design, if it's code compliant, the detailing of the rebars of the structure, are they strong enough? Okay. Especially when you consider earthquake loading, right? and and to to briefly introduce, I also have a part-time teaching or as a resource speaker in X structures. Okay, so in my approach in X structures is I discuss the code, especially this one, the skills I learned here, and reconcile with the theory, and I always discuss to the students why the code is this, because the theory requires this or something like that. Mm. And my last stint, sorry, second to the last is in SKM 2012 also. SKM, which was later bought by Jacobs Engineering. I think Jacobs Engineering is the #1 firm right now in the world in terms of revenue, not in terms of because engineering company has a lot of criteria to be determined as #1. You can be #1 on design, you can be #1 on the revenue, you can be #1 on the certain specific project. But I believe Jacobs is #1 right now in terms of revenue because they have oil and gas. Okay. But we as an SKM, we were just bought by Jacobs. Our project is mainly geothermal project. So our project in the Philippines was in Quezon, the Pagbilao Power Plant, in Visayas, the Thermal Visayas Incorporated Power Plant in Cagayan de Oro. So my skill in checking code compliance were used on this kind of project. We check the design of the contractors, those things. Okay. Okay. Then last company before I returned to academy is Arcadis. I think it's just 3 months. Arcadis. Okay. Our project was in Australia. Okay. Okay. Because SKM is an Australian company also. So I think uh, my main point, my main uh, advantage to transfer in Arcadis because I was in SKM, which is an Australian company. Okay. So with that, that's my short stint in industry, almost 10 years. Okay. So I returned to academe because I'm planning to take a PhD, maybe next semester, if God allows. No? Yeah. Okay, so still 21, or are there any missing? Okay. Okay. What are you oh, I'm sorry. What what are you looking at right now? What documents? I think I forgot to share. Is it a PDF or the journal?
The journal, sir.
I see, I see. So that's the screen. Okay. I thought I just shared the PDF. Okay po. So I think you already watched the overview of the subject, right? And again, in UP, the style is the major core subjects are advanced math. That's one, and numerical methods. Okay, numerical methods. So you need to take this first before you take the they call this core. I think core subject, and they have the major subject. Okay, maybe I'll just relate the one we have in structural engineering. As a major subject, we have the earthquake engineering, okay, the matrix analysis, and the finite. Finite. No, this not necessarily earthquake. Structural dynamics. Structural dynamics. Those are the major subjects. Then we have the electives, okay, which is earthquake, earthquake, RCD or concrete design or steel. So the electives could be different from each student. But if your path is MSCE major in structural, this core and major is required. Okay. This this one. Okay. I always said this, especially to new students, because this and I believe on this idea because you cannot understand the major subjects like finite, matrix analysis, and dynamics if you don't have the basic of these two, advanced mathematics and numerical methods. Okay. So if you are first year master students and you are enrolled in numerical, much better. Uh, I agree that you take up these numerical methods first, okay, so that you can understand the major subjects that will follow. Okay? Unlike unlike Jibril, which I just talked earlier, he was able to get earthquake first, RCD or steel, matrix analysis without having numerical and advanced math. So, but well, we're into UP, okay, because the subjects are based on the demand, right? So I understand. Okay. This is just the ideal for me. Okay, you first take the core subjects, the advanced math and numerical, before you take up the major subjects and the elective. Okay, or in parallel, numerical methods or other major subjects, like that. Okay, so maybe in other program like mechanical, this will also follow. For example, core subject, advanced math and numerical methods. In mechanical, I believe you have finite element, right? Although I believe finite element in even in structural here, finite is just an elective, right? But in UP, it's required. Okay? Because finite element analysis is the core of the programs we have. The core concept required in studying most programs right now. For example, in mechanical, you be using SolidWorks, right? If there are mechanicals here, okay. SolidWorks, it's finite element analysis subject. But to understand finite element analysis, you need to have the numerical methods first, okay, and advanced math. That's in structural, the same po. Do you have questions po ba?
For electrical po.
Electrical, ano? Ah,
Bale po kasi nung college po namin, meron na po kaming numerical
yeah, oo nga.
methods.
Yeah, oo. I think that's the good part of the electrical and ECE and even mechanical sometimes. You have numerical methods po, right? Sir Stephen, like, uh, have you downloaded yung yung ebook po?
Ang ginamit po kasi namin nung college is yung kay Steven Chapra po.
Yeah, it's the same. No? My approach is the
Okay
same
po.
naman po. Yeah, okay.
Okay.
So maybe you will pass the subject very easily. Okay. What program did you use po nung undergrad?
Excel po. Excel.
Excel. Oh, maybe we will introduce the a more like MATLAB, SMAT or MATCAD. Maybe that's the challenge na lang siguro on your part because uh, yeah, we will use SMAT. Okay. At first we will use Excel for the first chapters. If you watch yung simultaneous equation, right? You can solve problems using Excel. But in tridiagonal system, we will require MATCAD or SMAT. That's it. Okay. But huh. to be frank, I think if you know the looping in programming, it will be easy on you. Maybe in most civil po kasi, in most civil engineering, uh, programming using looping method was not discussed. So I believe here, I'll be demanding you, all the students, to learn the programming approach of numerical methods, and especially the looping. Well, you know, looping is is what you call that, is appearing on all software, MATCAD, MATLAB, Python. Okay, so it doesn't matter what software you will require, will use actually, but at least the concept of looping should be important, should be taken, should be demanded on you, most especially on you master students po, because well, it has it will be an advantage on you, no? And that's why you're taking up masters, to learn the concept. Okay, because again, yun nga po, because if you learn looping in numerical methods, all subject will be easy. That's my for me, that's my mantra, shall I say. That's my my that's uh my thoughts on numerical methods. Everything will be easy if you know the looping in programming, and you should learn it. You should learn when and where to apply looping. And with this subject, I think you will be enlightened, where and when to use that. Okay po? Because otherwise, if I did not demand looping on you, it will just be an undergraduate course. In fact, I believe in undergraduate, you also learn looping. So much more on your part, you should learn this. Okay. So first, I've already discussed system of linear equation. Uh, please watch na lang po yon. Okay. Don't worry, we will tackle that all again later on, maybe next 2 weeks or 3 weeks. Okay. But on my ebook, a draft ebook, according here, we should uh, first discuss roots of equation, solving nonlinear equation. Okay. So as a background, again, this is just a snapshot of the book from Gilat. This is the book Gilat. Yeah. It's downloadable in Google. Just search for it. Maybe I can share this copy later. Take note, he's a mechanical engineer, not civil. So proves that numerical methods is for everyone, in all engineering students. Yan po. So he used MATLAB here. Okay. So this is the content. So I just followed his content. Okay. Except I deleted Fourier, ano pa? Fourier lang, no? Kasi we normally in civil we do not use this always. No? Although we can use this, but not necessarily,
Sa
because
electrical
oh
po.
yeah, electrical. It's mostly used in electrical. So I
Yes po.
deleted this. Okay. Okay. We but in advanced math we tackle this, the analytical solution of this. Okay. So let's dive into chapter 3. So those are the graphs. Typical graph, okay, quadratic equation, right? Maybe since the chapter is roots of equation, so we're finding the roots. Okay, so if you have this kind of curve, the solution is only one because it touches the x-axis once, right? Okay, so here you have no solution because it does not touch the x-axis. Okay, in here it touches 3 times, so we have 3 solutions. Okay, because our equation is in f of x, which is y. Therefore, the roots of the equation will turn the f of x into 0, right? Such that your x is 0. Okay? So this is a nonlinear problem. No? In civil engineering, okay, where's my new page? To relate this to, I'll be biased on civil engineering, right? Because you know I'm MSCE. So when do we use nonlinear po? Okay. If you notice, I think in all engineering you know this. The stress strain of steel is something like this, right? Yan. So this is stress, this is strain. So at this region, we call this the Fy, or the yield strength. Okay. And in this region, Hooke's law govern, right? So say here, wherein stress is proportional to strain. Okay. But beyond that, this region is already nonlinear po. Okay. This is already nonlinear. Yeah. This is linear. Okay. It turns out that in structures, uh, okay, the graph is almost the same because still in structure, especially in concrete, it still dictates ductility. Okay, ductility. Because we're using RC, reinforced concrete. So it's a combination of concrete and steel. Okay. But in general, the steel actually dictates the ductility. Therefore, the graph of the force displacement curve of structure is something like this also. Say, most likely like this, and then becomes like this. So bilinear. So bilinear. Okay. So if I relate this, if your structure, if your steel rebar inside the concrete is undergoing on this stress, the relationship is linear. But the problem is, how do you measure the ductility of the structure, of the response of the structure, if your steel goes on this stage, which is nonlinear? And also the concept of design in civil engineering, in the code, is we expect our structure to go in elastic lateral displacement. Lateral displacement. Therefore, the code is expecting this to happen. So if the code is expecting the structure to behave like this, therefore, the stress strain of the steel will go, the actual stress of the steel will be on this stage. Okay. Now, how do you reconcile this stress strain to the nonlinear analysis? Nonlinear. So therefore, in to be exact, our structure should be analyzed in a nonlinear methods, right? So in civil engineering, we use, say, the pushover analysis as one of the methods to analyze the structure in a nonlinear way. And when we analyze structure using pushover analysis, the numerical approach is, of course, nonlinear. Okay? So when the numerical approach is nonlinear, this subject is important. Okay? And one of the the approach we use in the software, you will read the manual in software, is Newton's method actually. You will, if you will refer to ETABS, for example, you will see this kind of approach, Newton's method, which we will discuss later on. Okay, so that's my way of introducing the nonlinear chapter of numerical methods. Okay, because if your structure is, say, if it sends that your force is here, okay, therefore, how will your structure respond? Using Newton's method approach, which we will learn later, uh, you will be able to determine the response, which is in terms of displacement of your structure. Something like that. Using Newton's method approach. Okay. But the first one we will be tackling is bisection. Okay, we will be using bisection method. In bisection method, say this is your graph, we will assume an interval, okay, which is point A, point B. Point A, point B. And we know that if you assume this is your A, so that is your X, how do you determine the value of here? So if this is X, this is what? F of A, sorry. If this is A, this is F of A. If this is B, therefore this is F of B. Okay? So the idea is we assume a region A and B that will that is capturing the actual solution over here. Okay? And then substitute that A such that you learn F of A and you determine F of B, and then you determine the trending. And how do you determine the trends of the curve? Of course, midpoint A plus B over 2, you get the X and S. Where's the this is the algorithm, okay? This is the algorithm of the bisection method. We choose the first interval, A and B, okay? This means that F of A and F of B have different sign such that F of A times F of B is less than 0. For example, if this is your curve, that one, and this is your A, okay, and this is your B. This is your B. So of course, this is F of A, and this is F of B. Oh, sorry, F of B. So F of A, as you see on the graph, is what? Positive, right? It's above the x-axis. F of B, as you saw here, is negative, right? Okay. So using this algorithm, they have different sign. Okay. F of A is positive. F of B is negative. That means positive times negative is negative, and that is less than 0. Okay. That means your your solution is in between these two value, A and B. That's it. Okay. Now, what if uh, it's not true? Okay. So if it's greater than 0, therefore, uh, if it's okay, wait lang. Okay. The the best approach to demonstrate that is through example. For example, this problem, okay, 8 minus 4.5 x minus sine x. We assume, I'll give you a heads up. No? The actual value is this one, 2.4. Okay. So we know that the real solution is between 2 and 3, right? So get f of a. So substitute 2 into this equation, you have this 3 point something. Get f of b, substitute 3 into this equation, you have this, which is negative. Okay? And that is f of a times f of b is negative, right? This is positive, this is negative, so okay. Yan. Therefore, the solution lies between the two. Yan. Okay. How about x and s? So we determined already x and s. We now substitute x and s into this equation, which is negative 0.55. Okay. Negative 0.55. Okay. Paano ko ba mapakita yung isa pang PDF? If you will notice, f of a positive times f of x and s is negative, that is negative, right? So according to the PDF earlier, that means if this times this is negative, the solution is between f of a, the solution is between a and x and s, okay, which is true, right? Because the solution is actually 2.43. Okay, that's why uh, on the next iteration, we will assume a, instead of 3, we will now assume our b as 2.5. Okay, because we satisfy the 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 argument that x and s, f of a times f of x and s is negative. And if you satisfy that, that means your solution is now between a and x and s. So basically, that's just the algorithm. Okay, so let's do this. Okay, so for example, 2, 2.5, 2.25. Maybe let's further discuss this. So 2 and 2.5, your XNS is 2.25. Okay, correct? And f of XNS is positive. F of A is positive. So therefore, applying the algorithm earlier, f of A times f of XNS is positive, which is not correct, which is now not applicable, because as you will see, our solution is not between 2 and 2.25, right? So it's between 2.25 now and 2.5. Okay, that's why we will now turn our what do you call that, our boundary from 2.25 to 2.5. That's why if I substituted 2.25 here, it's not okay. So okay, that's it. Let's do this. No? So we implement that to Excel. So I'll open an Excel. Actually, I have it here now. So just to demonstrate. So 8 minus 4.5 x minus sine x. Take note, in Excel, when you use trigonometric, it's radian, right? So just be careful. That's why. Okay. So I have A, I have B, I have XNS, I have FA na lang lagay ko. F of A, F of A, F of B, and then, okay, wait lang. I'll just pause this first and then I'll just type in first the, okay, okay, wait lang. XNS, F of A, F of B, F of A times F of B, and then F of XNS, right? Okay, that's it. Okay. So first, let's plot this. How do we plot this? 8 minus 4.5. Okay, let's do this. So I'll assume x and then f of x. So our x, say from 0, oops, 0. Let's assume a 0.1, say 0.1 increment. So to do that, equals 0.1 plus the value above, right? And then I'll drag down this value. Okay. Next is then apply this this formula. So equals 8 minus 4.5 times x minus sine of this. Okay, and then enter. Okay, yes ko na lang. Okay, and then drag down. Yan. Okay. Then how do we plot this? So simply insert charts. Okay, maybe this one. This one. Okay, click this. Okay, delete ko muna. Delete first. I'll select first the data. Yan. And then insert so that it will automatically create a graph. So like that one. Okay. Oops. So this is the plot of 8 minus f of x equals 8 minus 4.5 times x minus sine x, which is a nonlinear equation. Okay. By the way, let me let me share where we got this equation. It's actually this equation. In order to solve uh, the area of a segment of a circle, which is it's a nonlinear equation, right? So f of theta is equal to 8 minus 4.5 theta minus sine theta. We wanted to get theta of a certain segment. Okay. Yeah. So we got the same curve like what we have in Excel here. And as you notice, our solution lies between 2 and 3. Right? And if you observe in our graph here, in our data, our solution is where f of x almost 0, right? Because we didn't get the value where f of x is actually 0. If you notice, between 2.4 and 2.5, the value turns from positive to negative. Therefore, the solution lies between here, okay? Between 2.4 and 2.5. If you wanted further to get the actual solution, if you wanted to approach to the solution better, let's assume an increment lesser than zero point 0.1, right? So say 0.01, okay? But that will be a lot of data or x and y's. Okay? So using numerical methods as we're doing, we can approximate, we can approximate the solution here. Okay. Okay, I'll let you think for it in 5 seconds. Because remember, uh, it's nice to view the graph, you know? But what if we cannot actually view the graph like that? So, so we were able to just guess the solution because we can show on the graph that the solution is just between 2 and 3. Okay, but what if we cannot? So that's why numerical methods like this is important. Okay, that's it. But it also turns out that with using the graphs, we can right away guess the boundary. Right? We know that the boundary will be between 2 and 3. Okay. Okay, so let's now move on to assuming A and B, 2, which is 3, 2 and 3. Okay. Then, so X and S, so the formula is simply equals A plus B all over 2. But take note, A plus B should be uh, inside a parenthesis. Yeah. Okay. Then f of A is equal to substitute A as substitute 2 into x. 8 minus 4.5 and then A minus sine A. Yeah. Okay, then enter. Yes, I forgot to include close parenthesis. So the same with f of b equals 8 minus 4.5 b minus sine b. Then close parenthesis. Okay, next, so multiply the two equals f of a times f of b. Yeah. So it's negative, okay. And then we can insert another column. So you can say solution between okay, solution found. Yeah. Equals, what's our criteria? If this is negative, right, is less than 0, then okay. Otherwise, not okay. Then close parenthesis, enter. That means solution between A and B. That's it. Solution between A and B. Okay, because the value here is negative. Okay. How about f of x and s equals 8 minus 4.5 x minus sine of x and s. Is this correct? Yes. Okay. Okay. Then I'll paste here another iteration number. So this is 1 equals 1 plus the value above. So all the way down. Okay. Okay, then I'll choose now, since solution is between A and B. Okay. Now another criteria is f of A times f of x and s. Okay, is equal to f of A times f of x and s. Yeah. Okay. I'll insert another column here. So it's negative. Okay. So the question here is the solution between A and x and s. Yeah. So same is equal to, just copy this, Control C, Control V. So if the value is, yeah, okay. So that's it. And the solution is between A and B. So 2 and 3. Also, the solution is between A and x and s. Okay. Therefore, in the next iteration, let's assume the boundary between 2 and x and s, which is 2.5, right? So I can now copy all this all the way down. Okay. Then I'll just change the values of A and B. So this become now an input, right? Okay, so let's now assume, okay, what's that?
Ay, yung sabaw niya matamis. Pero masarap siya.
Pala di ko
Parang
sinabawan.
nalilito na ako.
It's already 12 o'clock. They're talking about lunch. Anyway, so it's 2 and 2.5. Okay. X and S now becomes 2 and 2.25. Okay. F of A, F of B. F of A and F of B is negative. So solution is between A and B. Okay, yes. But is the solution between A and X and S? Not okay. So therefore, the solution is between, as you see, the solution is not between 2 and 2.25, right? So therefore, the solution is just between 2.5 and 2.25, all right? So I'll now type in 2.25 and 2.5. Okay. So what did the program said? Is the solution between A and B? Okay. Yeah, the solution is between 2.25 and 2.5. Okay. But the solution is not between 2.25 and 2.375. It says here, right? The solution is not between 2.25 and 2.375. Therefore, the solution is between 2.5 and 2.375. So I'll type in 2.375 and then 2.5. Okay. So as you notice, the program said both okay. Therefore, the solution is between 2.375 and 2.5. Correct. And the solution is also between 2.375 and 2.437.5. Therefore, we are nearing to the solution because the actual solution is 2.4 something, right? So I'll now type in 2.4375 and 2.5. Okay, not okay. So 2.375. Just change the A and B. 2.4375. Okay, so it's between 2 A and B. So it's between 2.375 and 2.4375. Okay, but not between A and X and S, but not between 2.375 and 2.40625. Okay. But first, let's have another column for f of x na lang. F of x. Okay. Copy this. So equals Control C, Control V. So what's my solution? So it will be x and s. Okay. Okay, this one. Okay. So it's between 2.4 is 2. So it's not between 2.3 and 2.4 because it's between 2.40625 and 2.4375. Okay, so it's still okay. Okay, so it's still between 2.40625 and 2.4375, but not between 2.4 and 2.42. Okay, so 2.421875 and 2.4375. Okay. I think, in fact, uh, it will now depend on you if how much tolerance you will accept. Okay. In this case, we already found the solution. If you tolerate, say, a point zero something solution, so you can say the solution is say 2.421875, because as you will observe, f of a is already 0.06, so almost zero. Okay. So admit. What else? So let's further. So it's still between 2.421875 and 2.4375, but not between 2.4 and 2.42. Okay. So 2.429688 and 2.4375. Yeah. Still, okay. If you notice, we're now on 0.006 tolerance. So I think, yeah. So you can assume the value, our f of a, our solution is 2.429688. Okay. So let's target this into 3 zeros. Okay, to accept the solution. So it's now between 2.429688 and 2.4375. So 2.433594 and 2.4375. 2.4, it's between A and B, and between A and X and S. A and X and S. Okay. This should be 2.429688, and X and S should be 2.433594. So that's it. Almost 0.006. Okay, our f of x and s is 0.0093. Okay, so our solution is 2.43. 2.43. Okay, so I'll let you study the algorithm for about 30 seconds. Okay. Okay, since we've already done with this, I'll give you this copy in chat. So I'll give you, say, 3 minutes to uh, tweak on the spreadsheet. Okay, so I'll save this. Okay, so it's already on the chat box. So please save that, and let's have a 3 minutes break. No? I'll give you time to tweak the spreadsheet. And okay. Okay po. So let's now proceed to by regular falsi method. Regular falsi method. Okay, so in regular falsi method, so let's refer to GILAT definition. There's regular falsi. So it's also called a false position in linear interpolation method. It's also a bracketing, but this time uh, we will assume our B into a fixed position. In some textbook, it's a fixed position method. Okay? So if you will observe the graph, B is fixed here, okay, and then the actual solution is here, okay. So you have this B, therefore this is f of B, and then first assumption of A is here, okay. And you will notice, of course, if you have A, you have f of A, just like in B, f of B. And we will get the slope, okay. As you will see, the slope will be decreasing or increasing as we approach to the actual solution, okay. That's why, resume share. That's why in the solution, you will notice f of b minus f of a all over b minus a. This is actually a formula of slope, right? In simplest term, this is more like mx plus b. So simple as that, okay? So m is this, okay? Then f of b is this, okay? Because we are assuming a certain boundary, then finding the slope, no, of our equation on those boundary. Okay. Where's my Excel? And so the algorithm is like this. Just choose the first interval, A and B, okay, such that the solution exists between them. Okay, and then f of A and f of B have different sign. Okay, so just like in bisection method, we use this argument. Okay, and also if f of A and f of x and s1 is less than 0, the solution is between A and x and s1. Okay. The approach is the same. It's such that the formula is different now. Okay. So in Excel, this is how we use. Allocate my regular falsi. Did I use the same formula, same problem? Yeah, it's the same problem. Okay. Uh, as you will see here, my A and B is this one. My B is fixed into 3. Therefore, I'm just changing my A value. Okay. So for example, I set the A and B between 2 and 3. Okay. Just like in bisection method, the same formula, f of A, f of B, f of A and f of B, negative sign. Therefore, the solution lies between 2 and 3. That's okay. X and S. So this time, our X and S formula is as we saw earlier in the book. Okay, one, implement that. Where is that? Here. This is your XNS, this one. Okay. After getting f of b and f of a, apply this formula. Okay. So that one. So a times f of b is f6 minus d6, which is the b. E6 is the f of a. Okay. All over f6 minus e6, f of b minus f of a. Okay. How do we derive that formula? You just have to set y equals 0. Yeah. From this formula. Okay, so let's try. Because remember, this is a slope intercept equation, right? So let's try that. Okay. So set y equals to 0. Oops. Okay. 0 equals f of b minus f of a all over b minus a times x minus b plus f of b. Yan. So transpose negative f of b minus f of a all over b minus a times x minus b. Okay. And then b minus a times negative f of b equals x minus b f of b minus f of a. X minus b. Our formula should be admit. X and S is equal to this here. Okay. F of b minus f of a, it's good. Okay, so transpose that on the left direction. So what we left is x minus b is equal to b minus a times negative f of b all over f of b minus f of a. Okay. Then transpose this negative b such that x will become now b minus a negative f of b plus b all over f of b minus f of a. Yeah. So x is actually this, x and s. For f of b, so our denominator is already correct. So if we rearrange this term, we will come up with this. Okay. Yeah. So if you rearrange that, of course, your denominator is still f of b minus f of a. And so okay. Yeah. So the implementation is in the Excel. So I'll send it also. Okay. XNS, f of XNS. Then here I introduce another formula. This time we are getting now the relative error. Yeah. So if you notice, the relative error is simply for example, 2 and 3, your XNS is 2.38, a relative error of 32%. The formula is 0.32 minus 0 because solution should be 0, right? F of x should be 0 all over the f of x, no, times 100. Okay. Okay. And our solution is 2.43. And as you notice, the relative error applying the same formula is now just 1%. Okay, so 1.38% here. And if you further apply the formula, you got a more exact, a more precise solution, 2.430465. The relative error is just less than 1%. So 0.000922. Yeah. Okay. So yeah, fixed B, yeah, changes A only. Yeah. So f of A, okay. So I'll send this also. Okay, so for example, 2 and 3, I got 3 for f of A, so it's correct. The solution is between A and B. And X and S is 2.38. Okay. Then let's assume our A now to be 2.38. Okay. Because we are fixing the B, right? So 2.38 and 3. Okay. Still the condition is okay because put in mind the solution is 2.43, right? So 2.38 and 3. So it's okay. Okay. F of X is almost 0 here, 0.02. Then the relative error is just 2.52. Okay. And then now let's change A again because f of X is almost 0 and the condition is met that the solution is between 2.38 and 3. Therefore, we can assume the new A as X and S because it's okay here. So 2.42727, f of A is this, f of B is this. Still, the condition is met. Okay, and f of X is now nearing almost 0, 0.001876. So what do you notice here? The convergence of regular falsi is faster, right, than the bisection method. Because in bisection method, your interval could change from two different region, right? Like not, but in this regular falsi, because we fix B, and then slope is now included in the formula, your slope will give you an idea that your solution is now, your assumed region is now nearing to the solution. So that's why the convergence is faster in regular falsi, this problem. Okay. So I'll give this spreadsheet again, and I'll give you a 3-minute break to digest the formula here. Okay, so file sent po, and then please download and check the formula. You can You can even modify other formula there. If you wanted to introduce uh, tolerance, okay, or say, uh, let's try changing the B. For example, say if I assume my B is say 2.3, you will notice the condition is not met already because remember the solution is 2.43 something. Okay? So if I assume B as 5, yeah, the condition is met, but definitely uh, you will need more data here in iteration because you need to further assume another A going to the 2.43 something. Naka-ano kayo, sir? You're using cell phone. Yeah, I'll upload later. But my first choice is in MS Team because that's our formal platform. So yeah, so a 3-minute break po. We'll start. Please. Okay, sige. I'll upload that now in our GC for your for your use. Okay. Resume. Which is Newton's method po. F of x and s. Okay, so share screen. So Newton's method. But before we derive the formula for Newton's method, let's tackle first Taylor series because we will be deriving the formula of Newton's method using Taylor series. Where's the Taylor series? Chapter 1. Yeah, this one. So Taylor series for a function of one variable. So it says here that given a function f of x, did I? Okay. Yan. So a function f of x, differentiable times in an interval containing a point. Taylor's theorem states that for each x in the interval, there exists a value x equals c between x and x equals x naught such that. Yan po. In layman's term, it's just that a certain f of x in one variable, function of one variable, you can expand that equation into this. Okay. Of course, f of x naught, okay, or for a certain value near the x, then using that x naught, x naught is an assumed x in this case. No? X naught is an assumed x. So x minus x naught, then first derivative plus x minus x naught square, 2 factorial, and then that it is associated with second derivative. Yan. This time, x minus x naught cube associated with third derivative. Yan. So on and so forth. Okay. Now for for Newton's method, we'll now go back to Newton's method here. We will just get the first two terms. Remember, this is the Taylor series in another form. No? F of x1 plus x minus x1. This time it's x of 1, not x naught. And then first derivative, 1 over 2 prime, x minus x1 squared, second derivative. So it says here, just get the first two. Okay, so I'll get the first two. That one. See? And then paste it here. Here. Okay? Yeah. And then with that, yeah. So our next solution will be xi plus 1. The second iteration will be xi, the current x, minus f of x minus all over f prime of x. Okay. So how is that? So where's my pen? If I operate that, so xi okay, f prime of xi, f of xi. So transpose this, and f of x is of course will be 0. Therefore, 0 is equal to f of x plus x minus x f prime of x. So that becomes negative f of x all over f prime of x is equal to x minus xi. Really entered the waiting room. Admit. Oh, sorry. Yan. So let's rearrange the term. So f of x is from the Taylor series. We got this. Okay. So this should be the formula. So we set, of course, f of x is 0 because we're nearing the solution, right? So f of x should be 0. So f of x plus x minus xi, then f prime of x. Okay. Then 0 equals this. Then transpose f of x. This becomes negative f of x. And then f prime of x will be in denominator. So x minus x will remain. And then transpose x sub I. So that becomes x sub I plus 1 is equal to xi minus f of xi. Oops, I'm using my mouse. All over f prime of xi. So see. So we got the same answer. So that's how important Taylor series is. Okay. So that means if you wanted to go more exact, you can use they call that the second derivatives. No? But it's Newton's method, no? So first derivative is enough. Okay. By the way, I forgot to discuss the derivation earlier. So I wrote it here in the x minus b. I stopped here, I think, equals b minus a. And then combining two terms, no? Of course, f of b minus f of a will be the least common denominator. So LCD is here, okay? And then b minus a multiplied to negative fb, distribute that. So I got this. Yeah. And then this one, the LCD here will be multiplied to b. So I have this. But it turns out these two terms can be canceled out. Therefore, what remains is this one, which is the same with our formula for x and f's, which we used in what do you call that? Regular falsi method. Okay, that's the derivation. And for the Newton's method, this is what we got. We were able to get the formula of Newton's method using the Taylor series expansion, considering only the first derivative. Okay, so let's now implement that to Excel. I think so. This is the formulation in Excel. Same problem. Okay, same problem. So xi, set a column for x sub I, the assumed first initial x. Then, of course, the f of xi, the value of the function on that assumed x. Then the derivative of that function on the assumed x. Okay. Then applying the formula we use in determining the next value, xi plus 1. So that is the assumed value, F2. Press F2, no, to determine the formula. The assumed value minus f of x all over f prime of x. So I got 4.522421. Okay. And f of x and s is negative, and then relative error is very large, right? It's negative 1,136 because we all know that the exact value is 2.4 something, and I started at 1, so the relative error is big. Okay. Next, so it suggested the next value should be 4.522. So input 4.522 here, get the f of x, negative 16, the derivatives on that, negative 5, then your xi plus 1 is 1.38. Okay. And f of x is 0.77. Relative error is still big, but this time it's I think the formula is 7. Okay, still big, no? But we're nearing the solution. Next, so it suggested 1.38. Okay, as here. Then f of x is that, f prime of x is that, xi plus 1 is that, and then f of x is this. Okay, large error pa rin. And it suggested 3.06, so input 3.06. Since this is a iteration, I just referred the next x sub I from the previous xi, right? Okay. So my xi now will be my xi plus 1 here. So as you notice, okay, it refers on the previous, refers on the previous, refers on the previous. Okay. Okay. Next is, okay, 3.06. So still large error. It's suggested now. As you notice, our xi plus 1 now is 2.45. No? From 4.522, the Newton's method is now referring us to the almost correct solution. That's the beauty of Newton's method, right? Unlike with the two previous method, your boundary should be on the vicinity, right? It should be capturing the solution. Whereas in Newton's method, as you notice, we're two we're far from the 2.43 something, but it automatically uh, divert our solution near to the solution. So that's why Newton's method is commonly used in the software. Okay, so especially in our case in civil engineering, okay, in nonlinear analysis of structures. Okay, so that's it. So once we were on the 2.45 vicinity, so the convergence is now fast. Okay, it's 2.43. That's it. Okay, so as you notice, the value is no longer changing. No? It proposes xi plus 1 similar to the previous xi almost. Okay, so that's the beauty of Newton's method, which was derived from the Taylor series expansion, right? So so the idea is if your solution was derived in Taylor series expansion, the solution is almost correct. No? The convergence is easier. Okay. Yeah. So I'll send this spreadsheet again. Okay, and then let's have a 3-minute break again for you to digest the formulas here. Okay. Okay, so let's now proceed to the last method for this day. It's the second method. Where is the definition? Second method. That's page 71. By the way, I'll send the copy of this PDF also. Formula. Maybe I just no parenthesis on the formula. Maybe on the Maybe you're referring to the title of the column. No? It will not affect. It's just a title po. Okay. And so let's I'll get a snapshot of resume share. Snapshot of the figure of second method. This one. Yeah, this one. So this is the solution. So the same with Newton's method. We're all again referring to the slope. This time, we will be using 2 point. For example, if we have assumed x1, therefore we have f of x1. Write down, where's my pen? If you noticed, the slope of this, I'll get the slope of this. So how do we get the slope of that? So that's simply f of x1 minus f of x2 all over x1 minus x2, right? Okay, is equal to. So you will observe that this slope is the same with the slope of this, right? Which is x2 and x3. Okay, so how do we now define the slope of this one below? So that will be f of x2 minus f of x3 all over x2 minus x3. Okay? But f of x3, okay, let's set this as 0. Okay? This one here is 0, right? So this becomes 0. Okay? It already touched here. If it's the solution, okay? And so, wait lang. Ayan, sige. Hindi naman ako nag-mute. Anyway, sige. Okay, yan. Xi minus 1. Xi minus 1. So the assumed next value is 2. So what's the value of there? Of the function there? Yeah. Then xi plus 1. Let's apply this formula we derived. Okay. So that will be equals xi, which is this, minus, maybe I'll paste this formula so we can have a reference. This one. that one. Then minimize. There. So xi plus 1 is equal to xi, which is 3, minus, open parenthesis, xi minus 1, which is 2, minus xi, which is 3. Oops, it's 3. Then multiplied to f of xi, which is this. Then close parenthesis, all over f of xi minus 1, which is this, minus f of xi, which is this. Okay, so I'll make sure there's parentheses all over them. I think this is good. Enter. Yes. Okay. So that's already correct. So our xi plus 1 is this now. Okay. Then f of xi plus 1, control C, control V. It's the same formula. Okay. 0.32. Okay. So I'll make this xi plus 1 now my new xi. Okay, enter. Then apply the formulas here. So just drag down. Right. Okay. So this becomes 0.32. Okay, xi minus 1 is, if this is 2, I'll make this now okay. So make this 2 also. Yeah. Okay. So see, 3, 2, and then this becomes 2.38. As you will see, our f of xi plus 1 is 0.32 at xi plus 1 is 2.38. So let's narrow down our value from 2.38 to 2. This becomes negative. Okay. slopes. So that's the second method. Our boundary is between 3 and 2. Okay. And second method, as you notice from the derivation of the formula, it's also a slope method because using the slope formula we derive, it approximates the solution from the assumed region boundary, and we are just changing xi in this case. So, and then it ultimately approximate the formula from the slope. Okay. So basically, second method is Newton's method is the same, no? But it says here on GILAT that if you approach close to each other, if you define a second line very close to each other, the method is actually an approximated form of Newton's method. Because as you notice, it's still a slope method. Okay. Okay. So with that, I'll send this spreadsheet again to the chat box in GC, and I'll let you uh, look into the formula in Excel, and that ends our discussion for today. Maybe the assignment will be next week, okay, because we still have the MOS, the method of successive substitution, for next week. Okay, do we have questions?
Okay naman po.
Okay po. I'll just maybe to wait. I'll just send first, no, before I announce other thing.